Okay, so in this video, I would like to teach you how to factor out the GCF from a polynomial. Okay, so greatest common factor, as you can see, that's what that stands for. And whatever you decide to factor out has to be a factor, keep saying that word, of each term, right? So if you look at the 18x and think, well, gee, I could factor a 6 out, but 6 doesn't go into 3, it doesn't go into 9, so that wouldn't work, okay? Now, some kids can look at this and just think, okay, 3, 18, 9, and they can just come up with the GCF in their head real fast. And this one is a little bit easier, but just as a refresher on how to do it in your calculator, if you go to Math and go over to Num at the top here, and then when you scroll, okay, and just hit clear, so Math Num, it's going to be option 9. So you can scroll and hit enter, or you can just hit 9. Now, it says GCD, that means greatest common denominator, but the same thing as greatest common factor. You can only compare two numbers at a time. I cannot put in 3, 18, and 9 at one time. So I'm going to put in my 3 and my 18. You have to separate the numbers with a comma. Now, I'm going to take this answer that I got, which is 3, I'm going to enter it with 9. So if I just go up here and highlight it and hit enter, I'm going to delete out my 18, put in the 9, it's 3. So my GCF is 3. Okay, again, you might have come up with that on your own. Now, the next thing you need to check is how many x's you can factor out. So when I'm looking at my terms, I have an x squared, I have an x, and I have no x. If I have a term that doesn't have an x, that means I can't take any x's out, right? Because if I wanted to factor out or divide out an x or an x squared, the 9 doesn't have it. So my GCF here is just 3. So I divide each of these terms by 3. Okay? So divide by 3, divide by 3, divide by 3. This 3 does not just disappear. It now moves in the front of the parentheses, and I divide. 3x squared divided by 3 is x squared. 18 divided by 3 is 6. 9 divided by 3 is 3. It's kind of like you're undoing, or the opposite of distribution, right? So if you would redistribute the 3 back in and multiply, you should get your original answer back, okay? But whatever you factor out has to go in front of your parentheses. It doesn't just disappear. These two polynomials have the same value, like they're equivalent. They just look different, okay? If you didn't write the 3, though, that wouldn't be true. Okay, so that's our final answer. We're just factoring. We're not like solving. There's no equation here. Let's move on to number 2. All right, now you can see there's no coefficients here, so I don't have to worry about doing this process in my calculator. I just need to decide how many n's I can take out. Now, when you are finding the greatest common factor, you are going to take the smallest or the lowest exponent. Okay, they're kind of opposites. Greatest common factor means you take the smallest exponent. So I've n4, n3, and n2. I am going to divide everything by n2, or n squared. So divided by n squared, divided by n squared, divided by n squared. Okay? Again, this n squared does not just disappear. It now moves into the front, and then I write my parenthesis. So now I'm doing n to the 4th divided by n squared. Oh, look, exponent rules. Oh, weird, we just covered that. Oh, now we need it. Oh, that's funny. Okay, so when I'm dividing the bases, I subtract the exponents. So I have n squared, and then minus. N cubed divided by n squared is just n. And then this guy right here, I will point this out, and I will probably still see this mistake. N squared divided by n squared does not equal 0. Okay? Let that sink in. This is not equal to 0. Anything divided by itself is a 1. So you have to stick the 1 there as its placeholder, right? If I were to distribute this n squared back into this parentheses, I need to get the same thing that I started with back. I need to get this back. If I didn't write anything here and I just closed my parentheses after these, after these two terms, again, that would not be the case. So however many terms you start with should be how many terms you have in your parentheses, okay? So don't make that mistake. You divide something by itself, you're left with a 1, okay? Again, that's my final answer. Okay, example 3. All right, so now I have 4k to the 4, 18k cubed, 6k squared. Okay, so again, if you're like 4, 18, 6, what factor do they all have in common? Well, you could start with 2 because they're all even. And if I'm looking at 4, if I focus on the smallest number, the only factors of 4 are 2 or 4, okay? 4 does not go into 6, it doesn't go into 18. 2 does go into those other numbers, so my greatest common factor will be 2. And if I'm looking at my k's, at 4, 3, 2, I take the smallest exponent. So my GCF is going to be 2k squared. I divide everything by 2k squared. That 2k squared goes in the front of my parentheses. And so there it is, right? It does not disappear. Now I divide everything by 2k squared. 4 divided by 2 is 2. K to the 4 divided by k squared is going to be k squared, right? Subtract the exponents. 18 divided by 2 is 9. K cubed divided by k squared is k. Minus 6 divided by 2 is 3. I have no k's left, so I just finish and close my parentheses. Okay? So the most common mistakes I see when students are doing these problems is that they don't write their GCF in the front. They just factor it out and then just, throw it away. And then the other mistake is what I mentioned up here, like saying that equals 0. But again, your calculator can help you out with the coefficients if you need help finding the GCF. And for the exponents, you're always taking the smallest exponent. Is that all the examples? That's all the examples. So try out the classwork. 12 problems. I hope you took excellent notes. Thanks for watching.